Alright. Um, this is my astronomy project, my final astronomy project. And in this project and video, we'll be talking about geocentrism, heliocentrism, and the solar system in general and how it works. I will be using the Universal Sandbox 2 simulator, which can be bought off of Steam for $20 or used in-game sharing with your friends. So, I will begin the video by talking about heliocentrism and geocentrism. Now, what we know today is that the heliocentric model is actually the correct model. It is the model that all astronomers use. It is the model that is the basis for all of astronomy. Well, for all of astronomy that's based upon the solar system, that is. And it is been proven over time and time again with countless accounts of evidence. We've been in space. We've seen the heliocentric model in action. But it's not always been like that. Back when people first started charting the skies, people assumed that we were at the center of the universe, which isn't too hard to believe, considering that if you were to stand on Earth and look up, you would see everything moving around you. Everything would be revolving around you, the sun, the moon, and everything else. And it's not hard to see why they saw it that way. However, this is not the case, as you can see on the simulation. This is how it truly works. Now, one of the first astronomers to start unifying the geocentric, which is the Earth at the center, was Ptolemy. He came up with something called epicycles for each planet. These epicycles were perfect circles that orbited the Earth, but they did not explain retrograde motion, which is what people were observing when they looked at the planets. Instead, he charted retrograde motion, which is basically the planets looping back and forth as they rotate around the sky. I will now demonstrate what retrograde motion is by going into actions and setting the Earth as the trail center. In doing so, I have created the illusion that the Earth is in the center of the universe. And if I speed things up, you should be able to see how retrograde motion works from the geocentric model. If you were to go onto the Earth and watched, let's say, Mercury, which is right there. Let me slow things down so it's easier to see. Let's flip things around so we're facing north. As you can see, Mercury is going across the sky normally, and this looks normal up until, if you wait, the planet starts to go downward and slow down, eventually going backwards. Just wait for it. There it is. It will stop and go back. This is what retrograde motion is, and this is what people have been observing and been confused on for many hundreds of years with the geocentric model. However, they did come up with this map, which looks something like this, of the planet's retrograde motion. And even though this is what they thought was happening, they couldn't explain why the planets were acting in such a manner. And it wasn't until the future astronomers came up with the heliocentric model, the Kepler laws, that unified everything. Now, of course, this isn't what's actually happening. This is just the illusion that the Earth is at the center. So if we focus our attention back on the sun and make it the set trail center, you could see that it's all just normal. But from the perspective of the Earth, it looked as if they had retrograde motion, which is very interesting. Now, the first astronomer to come up with the idea that the sun was at the center was Copernicus. Although he didn't have any evidence for this, he did mention the heliocentric model, but was swiftly dismissed as the Catholic Church supported the geocentric model and shunned anyone who disagreed with their beliefs. And he had no evidence to back it up, and people just discredited him completely. And it wasn't until Galileo Galilei used his discoveries to prove that the geocentric model was flawed. If we go over to solar systems and major moons, we're able to demonstrate what he did. First, he looked at Venus, and some might say like, you looked at Venus, that's cool. But By observing Venus's phases, he was able to use the Ptolemaic model and see the inconsistencies with the phases of Venus as seen from Earth. If the Ptolemaic model was true, the phases that he saw on Earth should not be what they are at certain times. For example, when you saw Venus as a full Venus, like as there was no crescent, it was like a full Venus. Particularly it wasn't supposed to be that type of phase, depending on the day in which the Ptolemaic model says it would be. Another thing that he discovered, if that makes any sense, I don't know if I explained that very well, but one of the most important discoveries he made was the Galilean moons, which is named after him for this very reason. That he discovered that there are four objects rotating around Jupiter, four major bodies. These bodies are Io, Europa, Ganymede, and Callisto. Now these moons are special because they were the first ever observed evidence that the Earth was not the exact center of the universe, that there was something other, there was another object in the universe that also had things revolving around it. Which is interesting because people thought that in the entire, all the stars and planets rotated around Earth, and Earth was at the center, but that's obviously not the case. And of course, the Catholic Church did not like that, and they put him under house arrest for the rest of his life, where he died. It wasn't until many years later where people started to accept the heliocentric model. The Kepler laws came out, Sir Isaac Newton developed his gravitational equations, and Albert Einstein with general relativity, and now we know the heliocentric model today. Now, time to go in about the facts about our solar system. Everything revolves around the central point, the sun, which is a star, a yellow star, and it is part of the main sequence, and it is an average star, meaning that it will last around 10 billion years or so before it dies out, and it is about halfway through its life. And when it dies out, it will expand into a red giant and engulf Mercury, Venus, and possibly Earth. That is the sun, and it is the main source of energy for all life on Earth. Next up we have Mercury, which is the closest planet and the smallest planet. Now Mercury is a little bit weird because it is one of the only planets, it is actually the only planet to be tidally locked to the sun, meaning that only one side faces the sun while the other is shed in darkness. This gives extreme weather conditions, meaning that the one that faces the sun is extremely hot while the backside is extremely cold. Now that led some scientists to believe that life could possibly be able to survive on the very edge of the dark and light, meaning that the temperature might be fine. There might also be some ice in the ice caps up top. However, that is highly unlikely. And if humans were to ever go over to this planet, we would need some serious reconstruction to be able to live on it. Now, Venus is our next planet from the sun. It is the hottest planet, weirdly, because Mercury is closer. But it is hot because of something called the runaway greenhouse effect. More than 95% of its atmosphere is made of carbon dioxide, which is trapping heat inside of it to make it the hot burning planet that it is. It can burn up to over 800 degrees Fahrenheit and is hot enough to cook a pizza in 8 seconds. This planet is the second brightest natural object in the sky other than the moon during the nighttime. It is considered Earth's twin not because of its composition but because of its size. They are relatively similar in size, which led some scientists to believe that maybe it possibly could have an Earth-like, Earth-like features. But obviously we know that's not the case. It is far from Earth, and no life exists inside of these clouds. However, there are some ideas about how humans could settle on this planet by having cloud cities that float above the clouds, which have a comfortable temperature. But that is in the very distant future. Another thing I forgot to mention is that Mercury is on an elevated orbital plane. As you can see, if we align all the other orbital planes of the planets, you see that Mercury is actually dipping and a little bit crooked. This is just a random little feature about Mercury, as it is an elevated orbit. It could have been possibly due to a collision, or it could probably just have started off this way, but nothing ever was close enough to intervene, which is interesting. It is very far out in its orbital plane. The next planet we have is Earth, the home of all life as we know it, and actually all life ever. There's never been any other life discovered, but there has been evidence that some other life may lurk on other planets, but it's never been directly observed. It is the only planet known to have a hydrosphere, and it has water on its surface, liquid water that is. Um, Earth has one moon, however the moon is so huge compared to its home planet, which makes it very special because without the moon we would not have our tidal forces that help keep the oceans at bay from engulfing the coasts. That is the first planet to have a moon. The next planet, it is also the first planet that we know of to have a magnetic field. The other two planets, Mercury and Venus, do not have a magnetic field. Mars is the next planet. One thing special about Mars is it is completely red. It is red due to the iron being oxidized, creating rust on the planet's surface. In fact, it is even theorized that the atmosphere may have been once mostly oxygen, or predominantly oxygen and nitrogen, possibly, more Earth-like in the past, and people suggested that it might have been a second Earth, like their life could have been existed. There's also evidence of riverbeds and river basins on the planet, and a fact about Mars is that it has the largest known volcano, well, largest volcano in general, in terms of size above sea level. It covers the size of Arizona and is dormant. Well, it doesn't erupt anymore, that is. It is covered in impact craters, so because of the lack of atmosphere to burn up all the meteors that might have landed on it. And it is theorized to have a small magnetic field on half of its hemisphere. However, but scientists believe that it once had a strong magnetic field that protected it against the solar radiation. But somehow the dynamo inside the center has stopped, ceasing the magnetic sphere, causing the sun to boil away the oceans and to strip away its atmosphere, leaving a barren, rocky planet. It has two moons, one of which is Phobos, which is destined to collide with Mars in a few million years. And Mars is very special because it is the only planet that we know of that can sustain human life. We could build colonies on this planet, unlike Venus, which is way too hot, and Mercury, which is way too close to the sun. This planet has a 24-hour day and has 1/3 the gravity of Earth, meaning that if humans were to ever colonize this, it could be terraformed into a second Earth in the distant future, which is nice because by colonizing this planet we can learn more about how life may evolve on different planets, and it could possibly have life deep in the soil that we could study, or fossils from ancient life. And next up we have the asteroid belt. The asteroid belt is home to Ceres and a bunch of other known asteroids that orbit the sun. Now the asteroid belt is home to most of the asteroids in the solar system, and an asteroid is basically a large body of rock. So some of these asteroids can range in size to small. Some of the asteroids can range in size from small tennis balls to large dwarf planets, even. And despite what you might have saw in Star Wars, you do not actually see a bunch of rocks in space. These are so far apart that if you were to fly through, there's a very low chance of you actually hitting an asteroid. However, the density of asteroids is pretty high in this region. Next up we have our first gas giant and the biggest planet in the solar system, Jupiter. Jupiter, as we discussed earlier, has 4 main moons: Europa, Io, Ganymede, and Callisto. And what's special about one of these moons, Europa, is that there's evidence that there's a giant ocean underneath that has more water than all of Earth's oceans combined. This leads scientists to believe that underneath may be billions of years of evolution of life, and possible multicellular life that could have evolved, and is being protected by the giant ice sheets that cover it. The ice sheets can go down to 7 kilometers or 7 miles deep, and the ocean underneath is only warm because of the tidal forces of Jupiter, giving it the warmth it needs. Um, Jupiter has 63 moons, which is a lot of moons. If you, well, it is the only planet that has more than 2 moons that we've discussed, and most of its moons are extremely small. However, these moons have been discovered through processes after years of technological advancement. Jupiter is home to the largest storm in the solar system, which has been lasting for many thousands of years, and is at least 4 times bigger than Earth, I believe. The recent Juno spacecraft actually discovered hexagonal patterns on the poles, which led scientists to believe that there are different types of storms that inhabit the poles of the planet. Jupiter gives off a lot of radiation, meaning that if we were to ever travel to Europa, we could never live on the surface. We would have to go under into the ice to study the life that may have existed down there. Our next planet is the crown jewel of the solar system, Saturn. Saturn is the only planet in the solar system known to have rings, and it doesn't show on this simulation. Give me 1 second. Go in this simulation, hopefully it'll show. That's weird, it's not showing anywhere. If we go to all planets and moons, it'll show. For some reason the simulation is not showing the rings of Saturn. However, Saturn does have rings. It has the biggest rings in the solar system, which span out for A, B, C, D, E, and F rings. The rings are made up of small fragments of ice and rock, and they are destined to disappear in a few million years, unfortunately, for Saturn, and the beauty of the planet will be gone. However, Saturn does have is the least dense planet. If you were to have a tub of water large enough, you could actually float Saturn into it. Saturn has the most moons in the solar system with 64 known moons, one more than Jupiter, and it is also one of the easiest to spot in the night sky, along with Jupiter and Venus, because of its rings. The rings can be seen through your average telescope. I also forgot to mention that one of its planets, if I can go back to solar system with major moons, go back to Saturn, where is she? It's one of its prominent moons, Titan, has been known to. Titan has methane oceans, which is surprising, and it may just have life as we don't know it, because life may be completely different on that planet, if there is any, of course. Now, there was a moon that Saturn has that had a recent discovery. Let me see if I can find it real quick. All the moons. Let me just go to Saturn and look for it. It has to be somewhere. Maybe it's. Let's slow it down so we can read all this. Enceladus. There we go. That's the moon I was looking for. And I don't know why I said this split in major moons. It's a pretty major moon. Enceladus, like Europa, also theorized to have a large ocean underneath its icy surface. And the recent discoveries of plumes found have shown that there's organic material, not organic life, but organic material in the oceans, meaning that if you were to put some of the microbes here on Earth into it, it would survive. Now, because of this, the Cassini spacecraft, which has been orbiting Saturn for the past few years, will finish its mission by driving itself into Saturn to make sure it does not contaminate any life that may be on Enceladus. Alright, let's go back to the major moons. Our next planet is Uranus, which is the best planet because of its funny name. Anyway, Uranus is one of the blander planets. It's just blue. And it should be lighter in color, actually. I don't know why it's really dark in this simulation. However, Uranus is strange because it is actually, if you look over here and go to materials and go down, or is it materials or is it motion? It should be in motion. Yeah. You can see that the that where is it? This is where I can't find it. In here. That's so weird. But this should be it, I think. No, no. Yeah, right here, axis. Yeah, so it has a 97.9 degree tilt, which is weird because it is completely on its side. It is theorized that it could have been collision, or it could have been the gravitational influence of other gas giants that made it rotate to its side, which means that the poles are actually, like, if you were to enable the, here, if I just double click and click edit, you can see where the poles are on this thing. It is completely on its side, which is interesting. Uranus, wait, hold up, doesn't do anything. Uranus has 4 major moons. Umbriel, they're not really that significant in the solar system compared to Europa, but they're there, and they've been being studied for a long time. Very little detail on the planet, nothing really cool. It was the first planet discovered in over 2,000 years, though, which is interesting. It has a really small ring system too, very unnoticeable compared to Saturn's amazing ring systems. Our last planet is Neptune, which is a little more detailed, much bluer in color. It was the first planet that was discovered without the use of a telescope. It was discovered by mathematical equations. It is named after a Roman god of the sea, and it is the strongest winds in the solar system. Some of these winds go faster than the speed of sound, and if you were to go on it, it would destroy your body. Just the winds itself, not including the temperature of the gravity, of course. It is the furthest planet from the sun, and it is the only planet that cannot be seen with the naked eye. This planet has its own moon, Triton, which is obviously named after, the god of the sea, and its extreme blue color gives it that name. It actually rains glass on Neptune, believe it or not, so don't go on there. Our next description is the Kuiper Belt. The Kuiper Belt is a giant collection of small fragments from the leftovers of the early solar system, and it includes our favorite dwarf planet Pluto, which is right over here. And obviously Pluto is not a planet anymore, but as an honorable mention since it was once a planet. It is not a planet anymore because it did not clear its orbital path. As you can see, it's all here, all this material that it cannot clear. And it has a moon, or as some scientists would like to call it, a dwarf binary partner, Charon. And a recent flyby of New Horizons discovered that Pluto may have more activity on its surface than one might have thought, and this might have more detail than one might have thought. Who knows what Pluto has? Oh, we just love it though. And that's about it for the main. There's some, some of these dwarf planets and asteroids that haven't been mentioned, but they exist. There's a bunch of asteroids that we named, like all these random names that we've been discovering, and we're keeping an eye out for any that might be a potential threat to Earth. None so far is known to hurt Earth. And if we go far enough, if I put on my grid, actually, we're able to see the distances. Now, at around this distance, there should be a sphere of debris called the Oort cloud. The Oort cloud is a giant expanse of fragments that have been thrown out of the center and been left on the outer edges of the solar system. The Oort cloud is home to trillions and trillions of different particles ranging from the size of a grain of sand to the size of large asteroids. It is not known what is out there, but there is a theory that a 9th planet is in the midst, right past the Kuiper Belt in between the Oort cloud, called Planet 9. If we pull this up here, this simulation actually displays an example of Planet 9, which is this. As you can see, this is the orbit of Planet 9. And if you go in here, Pluto is that close to the sun, and this is planet 9, which is so extremely far away. And it's not a surprise that we haven't found it yet. Planet 9, while extremely far away, has a 700 astronomical unit semi-major axis. An astronomical unit is the distance between the Earth and the Sun. So imagine how far that is. Its orbital period is around 190,000 years to orbit one full. Wait, no, I'm sorry, 20,000 years around there to orbit a full lap around the Sun. It is about the size of Neptune, 10 times the size of Earth. It's extremely cold and it's very dark. Scientists are still trying to find it, but the evidence that exists is also shown in the simulation over here, if it'll load. Its gravitational influence on these Kuiper Belt objects show that there has to be something out there with that amount of mass that's disrupting the orbitals of some of these. If we speed it up, you can see its gravity influences how these orbit around the Sun. And that's about it for the solar system, and that's about it for the entire video. A fun fact I should mention, one of my favorite facts about the solar system: if you took all the planets, including Pluto, and put in between the Earth and the Moon, they would all fit side by side with room to spare. It's true, look it up. Anyway, thank you. Also, I want to show you a few cool things before I end the video off. Here's a galaxy collision. Just thought you might enjoy this, Brusa. Speed it up real quick. Oh dear, there it goes. Oh yeah. I can make a whole other video about galaxies, but I'm not gonna, because I don't want you to create any extras. Yeah, it's taking my computer lag. As you can see, I made an elliptical galaxy. This is like what will happen with our galaxy in the Andromeda. What else was there cool to show you? I could show you this. Ain't that cool? Oh, they're colliding. Okay, this is not looking good, Bruce. Anyway, thanks for watching. I hope this presentation was cool and creative using the simulation. If you want any more simulations from me, or interested in how to use this, you can always ask Bruce. Thank you. Have a good day.